Hello, everyone, and welcome back to our series on knowledge tracing. Today, we're exploring a groundbreaking shift in the field with the Saint and Saint Plus models. These models completely abandon the sequential processing of RNNs and LSTMs in favor of the powerful transformer architecture. This allows them to process a student's entire history in parallel, leading to faster training and often more accurate predictions. Let's dive into how they work. Here's our agenda for today. We'll start with a simple analogy to understand the core idea of Saint models. Then, we'll break down their innovative separated encoder-decoder architecture and key parameters. We'll do a concrete calculation demo to see self-attention in action, including the time feature in Saint Plus. A crucial part of this discussion will be comparing Saint to previous methods like DKT and AKT. Finally, we'll explore how these powerful models can be integrated into your own research. To understand Saint, let's use an analogy. Previous models have limitations. BKT is too short-sighted. DKT can get confused by long sequences, and AKT, while better, still processes history in a sequential manner. Saint changes the game. Imagine a super assistant who doesn't read a notebook page by page. Instead, they take a snapshot of the entire notebook and use AI to instantly highlight all the most relevant parts. This is the power of parallel processing with self-attention. Saint Plus adds another layer of intelligence by also considering how recent each event was, making the model even more realistic. The key innovation of Saint is its separated encoder-decoder architecture. Unlike previous models that mix question and answer information, Saint treats them separately. The encoder processes the sequence of questions, building an understanding of the material covered. The decoder processes the sequence of right/wrong answers, building an understanding of the student's performance. The two are then combined to make a prediction. This clear separation of concerns leads to better modeling of both the content and the learner. Saint Plus further enhances this by adding a time embedding to explicitly model the passage of time. The magic of Saint lies in the self-attention mechanism and its key parameters. The D model and N head control the model's capacity and its ability to look for different types of patterns. The projection matrices transform the raw data into the query, key, and value vectors that the attention mechanism uses. The formula for self-attention is elegant. It calculates how relevant each piece of history is to the current task using Q and K, converts those relevance scores into weights, and then uses those weights to compute a weighted average of the historical states using V. This gives the model a powerful, flexible way to summarize the past. Let's walk through a concrete example. For Saint, we calculate attention weights by comparing the current question to all past questions based on their features. The most similar question gets the highest weight. Using these weights, the model predicts a 74.7% chance of success. Now, let's add time with Saint Plus. We introduce a time decay factor. The most recent and similar question, Q3, now gets an even higher weight, while the older similar question, Q1, gets a lower weight. This demonstrates how Saint Plus makes the model more sensitive to recency, leading to more realistic predictions. This is a crucial question. Saint represents a fundamental shift from previous models. DKT processes history sequentially, which is slow and can lose information. AKT improves on this with attention, but is still sequential. Saint, however, processes all history in parallel, making it much faster and better at capturing long-range dependencies. It also cleanly separates the modeling of questions and responses, leading to better performance. Saint Plus further refines this with a sophisticated, learnable model of time. The result is a model that is faster, more accurate, and more interpretable than anything that came before. Saint Plus offers incredible advantages for your research. Its parallel processing is perfect for handling large datasets quickly. The separated encoding makes it straightforward to integrate your multimodal data, like eye tracking features, into the model. The explicit time modeling aligns perfectly with your work on cognitive fatigue and forgetting. You could, for example, use your fatigue metrics to dynamically adjust the time decay in Saint Plus. The model's output can be used not just to predict correctness, but also to calculate the distance to the optimal challenge zone, enabling precise, data-driven interventions. Let's summarize. Saint and Saint Plus represent a major leap forward. By adopting the transformer architecture, they process a student's entire history in parallel, making them incredibly fast and effective at capturing complex patterns. The separation of question and answer sequences leads to more nuanced modeling. Saint Plus adds a sophisticated model of time, making it highly realistic. The result is a model that is not only more accurate but also faster to train and more interpretable than ever before, truly representing the cutting edge of knowledge tracing technology. That's all for today's deep dive into Saint and Saint Plus. We've covered their core ideas, calculations, and how they represent a significant advance over previous methods. Now, I'd be happy to answer any questions you might have. Thank you for your attention. Thank you for watching. If you found this video helpful, please like and subscribe for more content on educational data mining and knowledge tracing. See you next time.